Welcome to C# for Crestron programming. C# for Crestron has a datastore class that operates in a similar way to the analog, digital, and serial RAM symbols in Simple, but also can share data globally with all C# for Crestron programs and C# for Crestron modules on the same processor. It allows you to save data that will survive program reload and restart, as well as power loss, without having to create your class library to write information to a file. It is perfect for remembering the last volume level or light levels, or what features were turned on or off, as well as user-generated labels for favorites. Example code is available for download. The using statement for Datastore is Crestron Simple Sharp Crestron Datastore. When you first explore the Datastore, you can implement it like a standard class and instantiate it. But that has been superseded by the static class version. You should use the static class version. Here we initialize the Datastore for use by calling the method to initialize the Crestron Datastore. We are performing this in the initializeSystem method, but it can be performed anywhere in your program. Just make sure you initialize the Datastore before trying to read or write to the Datastore. In the next line of code, we set the global access parameters. Here, we are setting global to be owner, read, and write, as well as all programs and modules to read and write. You can set global access to have tighter restrictions by exploring the CSDA flags enum. The program has two custom console commands to set, read, and clear both the logical and global Datastore locations. This example is going to use strings. You can store many more data types. Each data type and storage location must have its unique tag name. getLocalStringValue is used here to retrieve the string that has the tag name local string, and we use the out directive to allow the method to modify the variable we created for easy access in our program. We also check the return to see if it was successful or not and generate the appropriate response. Here, we are loading the responses into a local variable so that we can display the error to the user. To write a new Datastore item or update an existing one, the setLocalStringValue method is used. We specify the tag name used and the string we wish to store inside it. Once again, we will get a success or an error, and we can check for this and compensate for it or warn the user. Finally, we can clear the local variable with a clear local method. This will remove the tag completely. Trying to retrieve the tag, if it is not rewritten, or if it was cleared, will throw an error of record not found. Global Datastore is identical except for using the global methods, and access is determined by the access flags set to the class's global access parameter we set in the initialize method. We can compile and upload to test the Datastore. Loading the same program into two separate program slots will allow us to test that the global Datastore is shared across slots. We allow both the owner or creator of the global tag as well as the other programs to have read and write access. This allows access from both programs to the same storage location for reading and writing. Using Datastore allows for a quick and easy way to remember information across program restart, power loss, and processor reboots, as well as sharing that information across multiple programs so they can be aware of that stored information and update it as well. Thank you for watching.